Okay, in this video, I'm going to show you how to find the absolute extrema of a function involving natural logarithmic function ln. So I have this function, f of x is 11x squared minus 2 times the natural log of x squared. And we want to find the absolute extrema, so the absolute max and the absolute min of this function on this interval, 0.05 up to 8. This function is actually, the natural logarithmic function is undefined at x equals 0. So that's why we're starting a little bit to the right of it at 0.05. So there are two kinds of points at which the absolute extrema can occur. One is at a critical point of a function where its derivative is equal to 0 or undefined. And also the endpoints of the interval, so either at 0.05 or at 8, so we're going to check those two. First, let's get critical points. So f prime of x, derivative, is going to be, so 11 times the derivative of x squared, which is 2x, minus 2 times, now the derivative of the natural log of a function is 1 over that function, times the derivative of that function. So times the derivative of x squared, which is 2x. So now I'm going to clean this up. So I have 22x, and then I have 4 x over x squared, but that's the same as 4 over x. And I need that to be equal to 0 to find critical points. This function is defined in the entire interval, so we're not going to look at where the derivative is undefined, just where it's equal to 0. Now, to solve this equation, what I'm going to do is move the second term to the other side, so 22x is equal to 4 over x. Then I'm going to multiply both sides by x. So I have 22x squared is equal to 4. Now I can divide both sides by 22, so x squared is equal to 4 over 22, which is the same as 2 over 11 in lowest terms. So therefore, x is equal to the square root of 2 over 11. Now, really x is plus or minus the square root of 2 over 11. I'm going to ignore the negative square root, because that is not in the interval. I only want to consider critical points that are actually in the interval in question. But now I need to make sure that the positive square root is an interval. So 2 divided by 11. Okay, square root is 0.43 rounded to 2 decimal places, and that is in the interval, so we're good. So that's one place where an absolute maximum or minimum can occur. So my candidates for locations of absolute extrema are my x values would have the left endpoint, 0.05, the critical point, 0.43, and then the right endpoint, x equals 8. So all I need to do now is substitute each of these x values into the original function, not the derivative, the original function. And smallest value is absolute min, largest value is absolute max. So if I substitute in 0.05, so substituting in x equals 0.05, so I have 0.05 squared times 11. Again, I get 0.0275. And then for the second term, ln of x squared is the same as 2 ln x using a properties of log. I can take this 2 and pull it down. So the second term of this function can be found as minus 4 ln x. And that'd be a little easier from the calculator. So I have 0.0275 minus 4 times 0.05 natural log, and the result I get is just positive, because I have a minus 4, but the natural log of 0.05 is roughly minus 3. So I have 12.01 to 2 decimal places. Okay, but now I'm going to substitute these other values and see what we get. So I have 0.43 squared times 11 minus 4 times 0.43 natural log equals, that's a smaller value, so it's 5.41 in 2 decimal places. So that's best candidate for minimum, this is best candidate for maximum. But I have one more value to substitute in, that's 8. So I have, so 8 squared is 64 times 11, it's pretty big. And then minus 4 times 8 natural log. And what I get is a pretty big number, 695.68. Okay, so this value right here is my absolute minimum, and this value right here is my absolute maximum. And these are the x values at which